Sometimes dependency between two activities may not be a straightforward one, like finish one and start the next, or start one and then start the next. Some relationships require that there is a gap or an overlap introduced between the two activities. So let us first take the need for gap and look at it with the help of a couple of examples. Two activities: pour concrete in the ceiling and then remove the formwork. What will happen if formwork is removed right after the concrete pouring is finished? The ceiling comes down, collapses. This situation requires that there must be a gap between the two activities, a delay. Once ceiling concrete is poured, it is left for few days. For sake of discussion, let's say 7 days, and then the formwork removed. This is where a lag is introduced in the network diagram between the two activities. So it will look like pour concrete, wait for 7 days, then remove the formwork. Now, what will happen to that 7 days of delay if the pouring of concrete is delayed? It stays. It is not depleted. It is not eaten up. It will move as much as the delay. So when the concreting is finally complete, sometime later, there will still be a wait for 7 days before the formwork is removed. What I am really saying here is not to use lags to cover up for chances of delay. We instead use buffers for that purpose. Let us look at another example. Two activities related to book writing: write draft and edit draft. The relationship between these two has been put up as start to start. Now, honestly thinking, is it possible that the writer starts writing on day 1 and the editor starts editing on day 1? What will the editor going to edit on day 1? So you can see that some delay is required between these two activities. A delay to make sure that there is enough draft available that the editor can start editing. So a lag can be put in here. Let us say of 1 week between the two activities. A lag is almost always represented by an addition or a positive sign to show that time is being added. In the first example, the lag is shown as fs plus 7 days, which is finish predecessor, wait for 7 days and then start the successor activity. In the second example, the lag is written as ss plus 1 week, start predecessor, wait for 1 week, then start the successor. Now, there can be a need to start an activity before it is to be started according to the dependency. A start to start relationship or a finish to finish relationship makes activities work in parallel. In the early example, we saw that a lag can be put to have a delay between the start of two activities. The activities were running in parallel once both have started. The other method is to introduce a lead. Let us look at an example. Design an app, then code the app. The usual dependency is finish to start between the two. Design the app will take 60 days and code the app will also take 60 days. In total, it will be 120 days. Now, ideally, coding the app should be started once the design is complete, but maybe 120 days is taking too long and the management or the customer requires that this work be done earlier. So, in that case, a lead can be used. Instead of waiting for the design to complete, once enough design is available, coding can be started. So let's say once 40 days of design work is done, coding is to be started. This will be shown as finish to start with a lead of 20 days. In other words, we are saying that when the point is reached that only 20 days of design work is left, start coding. It is shown as fs minus 20 days. What will happen if the design gets late? Well, if the design work is late in the first 40 days, the coding will be delayed. But once coding has started, this activity is independent from the network logic perspective. though in reality it cannot be completed without completing the design work. Scheduling software do not allow building a circular logic. So two activities can only be connected on one side and not both. You, as the scheduler, have to decide which relationship gives you better control. Look at the two activities. Design app, code app. The dependency can be created as finish to start with a lead of 20 days, start to start with a lag of 40 days, and finish to finish with a lag of 20 days. All three are valid ways of creating dependencies using a lead or a lag. Which one is best? You decide. In this example, I will prefer to use finish to start with enough buffer that if there is a small delay in the remaining 20 days of design work, the coding is not impacted. I have explained the concepts of lead and lag. Now we understand that lags are used to introduce delays between activities and leads are used to start activities earlier than when the dependencies are asking.